So I'd like to welcome everybody to the December 2018 Mississippi PowerShell User Group meeting. Tonight we've got Josh King who is speaking on Whip Your Scripts into Shape, Optimizing PowerShell for Speed Redux. Take it away, Josh.
Awesome. Thanks, Mike. Yeah, so this is a update to the presentation that I gave at Summit earlier this year. Which I had a lot of fun presenting at the time, and yeah, every time I present this or something similar to it, there's always good discussion, so I've been trying to build on it over time. So, I'm Josh King. You can find me on Twitter at WindowsNZ, and you can find my blog over at king.geek.nz. And you might be able to tell from the accent I'm not from America. So I'm actually from New Zealand, and specifically I'm from a small town on the east coast where it's always really sunny and normally hot, except for like one day during winter. And I actually work for the local city council. So we're the district council for. We're located in a city, but I guess by American standards, we're tiny. So, the topic of today is PowerShell and speed. And the unfortunate reality is that there's a bit of a bad perception around PowerShell and speed, especially from people that are coming from other .NET languages like your C#, that are used to things being compiled and running a lot faster. But a lot of it is also due to startup times. And let's face it, if your startup time, the first time you load up PowerShell is kind of slow, it's going to taint your perception of it. And it is, unfortunately, a really common complaint. So it's, yeah, you just search PowerShell and slow on Google, you get a ton of results. I actually, leading up to Summit, I had a alert set in the Slack channel for anyone saying slow in the main help channel, and I was getting pinged a lot. So, yeah. Now, what we're going to do to have a look at this is we're going to be doing some A/B testing, and I am bastardizing that term a little bit. But what we're going to be doing is making changes and looking for improvements and measuring the differences. We'll be doing one change at a time, and I guess it's like anything in IT, unless you're only changing one thing at a time, you don't know what actually fixed the problem. So like, if you've got a network issue, you don't go running out and changing the network card, the switch, the patch leads, all of that at the same time, because it was probably just the patch lead or the network stack or DNS. And test more than once. So whenever you're doing this sort of testing, there is the very real possibility of random occurrences or extra things running on your PC or just sheer luck changing the outcome of your tests. So you test many times, you look at the trends, and you account for any outliers. And unfortunately, taking measurements in and of themselves are going to introduce a performance impact, so you've got to try and keep that to a minimum. Now, how I'm going to be running my test cases today is with a module that I've written called RunBucket. And basically what that does is it takes a script block in as our control, and that control is going to be, quote unquote, your standard way of doing something. And then it takes in another script block, which will be our variation, and that's something that we can do differently. And then we give it a title and run it. So a little bit more about RunBucket. It does use posh RSJob in the background, which is my preferred method of running parallel jobs. And we're doing that because we're doing tons of test cases at the same time, and we really don't have the time to sit here and watch them go through in sequence. I'm doing by default 100 iterations of each test case. you might see on some of the calls that I've got a dash iterations and a number that's lower than that. That's generally just because those particular tests take too long and we wouldn't be able to sit here and wait for 100 of them to finish. And just to try and smooth out any outliers, I ignore both the slowest and the fastest results out of those 100 iterations. And I average and do some other statistics on the results as well. Now, how I'm actually taking the measurements is instead of the measure command cmdlet, I'm using the stopwatch class out of .NET. And this really only comes up in the first test, spoilers, but measure command actually drops console output. So if part of what you're measuring is the impact of console output, measure command's not going to reflect that for you. So that's part of the reason why I'm using stopwatch. And there might also be something in there about using .NET classes instead of commandlets. And then my results are displayed via Adam Driscoll's PowerShell Universal Dashboard, just to give us a nice display. And I'll run that through as a demonstration, well, as an example before we actually run our first case, so you know what you're actually seeing on that dashboard. Also, you're going to be seeing some notifications pop up, and these aren't Slack notifications. They're going to look something like this. The reason why I added this slide is because the first time I did a demo or a dry run of this at work, is these notifications were popping up through my demo, and because I didn't address them up front, people got distracted by them more than they probably should. So all these do is tell me that my test cases are finished, because as you'll find out, I'm not actually running any of the code myself. It's all happening in the background automatically, and without these I don't know that they're actually done and the results are ready. So yeah, they indicate that all my tests are finished, and they're created via the Burnt Toast module. So let's jump over to code, and let me know if that is or isn't big enough. Just feel free to interrupt me, Mike, or whoever can see. In fact, it's on my screen too. Let's load it up just a touch. Cool. So we're going to be running through 11 concepts, and that's going to be encompassed within 16 demos. And then at the end, we're going to have a PowerShell Core bonus round where we're comparing Windows PowerShell to PowerShell Core. So on that front, the main test cases are all being run in Windows PowerShell. As far as I'm aware, they all should run in PowerShell Core, but I haven't had enough time to actually guarantee that's the case. These demos might have unexpected results, and that's sort of the point. So every time I've run through these, sometimes the margins are a lot closer than I expect, other times they're a lot wider than I expect. Sometimes the completely wrong result happens, and that's not fun. But so I haven't cherry-picked the best possible case examples for each of these. In some cases I've picked examples that are just fun, and I enjoyed it. I'm using numerous Visual Studio Code and PowerShell tools, and if you're interested in any of the mechanics behind that, hit me up on Twitter. You'll also find a bunch in the GitHub link at the end. And you won't see me running any code myself, and it's all happening automatically as I pull up the test cases. So, this is the dashboard where my results are being displayed. This example here, you can see the name of the test case up the top, so this is just an example. My control is actually just sleeping for a couple of seconds, and my variation is not. So obviously this one's going to be a lot quicker. And I label the column with the winner in it, so controls on the left, variation in the middle, and the percentage difference on the right, with a negative number being a speed up. So obviously the average of 19 milliseconds for my control versus 0.3 milliseconds for my variation. It's a 98% speed up. How I'm determining the winner is based on that average, but I do include the minimum and maximum runtimes here just to give a bit of context around that as well. So, code and pull up our first test case. So I mentioned console output as the reason why we're using a stopwatch, and this example here is a little bit in and of itself, it's a little bit of an outlier from the rest of my examples, because with all the other ones I try and keep the output of them exactly the same. But in this case, my control is listing out all of the files in my drivers directory, whereas my variation is assigning that output to a variable. So ideally I would normally have had both of these resulting in an items variable with the same content, but for the sake of demonstration, we have way closer of a margin than I'm used to. So yeah, luckily my maximums do show a bit of a better picture of this. So my control, excuse me, my control for this example, which again was listing out all the contents of my drivers directory, the maximum runtime there was 145 milliseconds, whereas my variation, which was assigning it to a variable, is about a third quicker. Normally I see my averages a lot further apart than this, but in this case, not so much. But I guess where I'm going with that is if you don't output stuff to the screen just for the sake of outputting stuff to the screen. You can have it obviously for debugging and for your verbose output, but if you don't need it on the screen, don't put it on the screen, especially if it's a headless script anyway. Right. Next is filters. So one of the first things we hear when learning PowerShell is format right, filter left. And I think conceptually we all understand why, but from what I've seen, not many people actually test it. So for my control here, what I've done is I'm getting a bunch of win events from my application log, and I'm filtering out to get a specific ID and only events that were created in the last hour. So and then assigning that to the events variable. So what that's going to do is it's actually grabbing every event from my applications log, chucking it through the pipeline, and then applying the filtering to it. Instead of doing that, there's actually a filter hash table argument on the getWinEvent commandlet, and we can specify directly on that our our log name, the ID we're looking for, and the time created. So the difference there is pretty massive. And this was a pretty good one because filtering was literally the second thing we did on the pipeline. So like you could imagine if we left the where object to 2 or 3 items down the pipeline. But our control there with piping to where object netted an average of 179 milliseconds. But just by bringing that filtering in even closer, well, as soon as humanly possible, we drop that down to 20 milliseconds, netting us a speed up of roughly 90%. One thing I forgot to mention, of course, is all of these test cases are small because of the nature of this sort of format for the talk, given we've got, say, 45 minutes to an hour. If you scale these results out to huge data sets or huge environments, it's obviously going to make a difference. So a peek behind the curtains for these Windows event log ones. I often have to clear out my event log in the morning before doing these demonstrations, so that this actually completes in a reasonable amount of time, because of my control. If I leave it, it takes way too long, even with only 5 iterations. Yeah. So, on to the same sort of concept. We're still looking at Win events. This is a concept I like to call, well, single touch. You can see it in the file name there. But in this case, we've learnt about the filter hash table. We know the speed improvements it gives us. And now I want, some events from my application log. We'll put that in app events. I want some events from my system log. We'll chuck that in sys events. So that's making 2 calls to the event log with 2 different uses of the get win event commandlet. Excuse me. However, it's actually possible to provide two log names and 2 IDs to get win event, and then we can use the where method to split those out, so we end up with sys event and app event in both cases. Now, I have made sure that I'm using IDs that are only present, so there's no 7001 in application that I was able to find. So in theory, in all of my cases anyway, these 2 are the same. So yes, to be fair, this might not always work in every use case, but in this one it happens to. But again, the margins here are really, really tight. Where I've actually found this to be a lot better, but unfortunately kind of hard to demo when I don't always have access to a full lab, is with Active Directory and grabbing user accounts out of different OUs. In that case, I tend to see about depending on the size of the OUs, about a 10 to 25% increase. That may or may not be just because of the Active Directory module itself. But so yeah, it's always good if you're dealing with a remote source or some source of data to only touch it once and then handle filtering and that yourself. If that makes any sense. Now, verbosity. So one of the things PowerShell is surprisingly good at is letting you write short one-line commands where you can actually be kind of cryptic and make it hard for someone that's not quite as versed in the language as you are, kind of confused. So my control here is using all the aliases I could think of. We've got service instead of get service, question mark instead of where object, select instead of select object. Instead of specifying first, I've specified just F, which was unique enough to get that that parameter. And my variation is just spelling all that out as succinctly as complete as possible. The difference there, and this one really surprised me, is about 60%. So our average runtime there has gone from 9 milliseconds down to 3 just by expanding out those aliases. Now I'm pretty sure the actual cause of most of that speed up is specifying service here, because PowerShell is doing a lot of gymnastics of sorts to get to the end result there. So if you don't know what's going on there, if you specify a get commandlet without the get, it eventually figures itself out, but what it's doing is it's going through a stack, and I sometimes get this order wrong, but if I remember right, it looks for a function first called service. When it doesn't find that, it looks for a commandlet, Then it drops down to the file system and looks for something it can execute, like a exe file. And then it appends get and goes through that list again. So then it goes get service and looks for a function, and then the commandlet, and then it finds that and finally runs. So it's doing a lot of guesswork there to figure out what you actually wanted it to do. And you run the risk of somebody potentially chucking a service in there called, a function in there called service, and intercepting that that execution anyway. Now, we've seen a lot of pipeline use so far. Let's have a look at what the impact of the pipeline actually is. So you will have remembered earlier that I used the where method, and perhaps I should have put this demonstration first to show you why, but that character there, the pipe, has a lot of overhead associated with it, and I'm hoping the demonstration shows that that's the case. And one thing I forgot to check is whether or not there's actually something in my temp folder. So this could be a very interesting demo. So what this is doing, our control, is it's listing out the contents of my my personal temp directory on my C drive, and then I'm looking for files that are greater than 5,000 bytes. Whereas my variation is doing the same thing, but instead of piping the where object, I'm using the where method, which was introduced in, it was either PowerShell 3 or 4, and that's another one I should probably put in my notes because it comes up every time. If we look at that, we get a speed up of about, well, over 10 milliseconds, which in this sort of scale works out to 38%. So, given we're only dealing with a small data set here, and we're dealing in sub-second times, you can sort of appreciate the difference of 10 milliseconds isn't a lot, but if you applied that to something that took 10 minutes, and all of a sudden you were shaving that down to just over 6 or 7, yeah, it's a massive time saving as you scale up. Just by removing that character. So along the same lines is loops. And this example here is again using the pipeline, and it's also using for each. Now, the for each in my control and the for each in my variable, my variation, look very similar. However, this is actually an alias for each object, which is a commandlet, whereas this for each is a statement within the language. So not only are we piping it through a construct that has overhead of its own, we're dealing with a commandlet, which we'll look at in a sec, has overhead in and of itself, and we're using an alias. So largely this is the same as my previous example where we're looking at items in my temp directory, but this time I'm totaling up the total length, and I'll end up with a total length variable at the end. And again, we're looking at about the same speed up here. So just under 40% and just over 10 milliseconds for this particular folder. And again, remember, you scale this out to a bigger data set, you end up with about the same percentage speed up. So say if it took an hour, it now maybe takes 40 minutes, which is really good. And we're just about halfway. So we've got 3 demos on operations. Now this one probably don't need to leave in anymore, but I include it because I didn't know about this until I was building this demonstration for Summit. But I was trying to compare the version of an installed piece of software on all of our machines against a string. And for the stand-in for the version of my software, I'm actually just using the version of PowerShell. So if you've never looked at PowerShell version table, and specifically the version within that, you get an object out that looks like this, with a major, a minor, a build, and a revision. And I want to test against this version. So initially when I sat down to do this, I thought, all right, sure, there's my major, there's my minor, and there's my build. I can just split that on the period, and then I'll go through this entire if-else loop, if-else structure, and if it matches all of those, comparing that to that, that to that, and that to that, I'll spit out true, and if anything else happens, I'll spit out false. What I didn't realize is I could cast my string as a version, and then just compare the two directly. So, if I remember correctly, this one is a very tight... That margin doesn't look very tight, but consider we're less than a millisecond here. So, like I say, this is really not a good example, but I like to include it because of the learning I went through to get to the end of it. But yeah, again, we're at another 40% increase. But we've gone from 0.7 milliseconds to 0.4. The moral here, though, is quite often you can find yourself going down a path where you're carrying out a lot of operations that you don't need to do, but it does require some knowledge of the language. So it's not something you can just be expected to know that you can cast a string as a version and get going. But once you've got that, you start to look for other things that you can do that same sort of thing and get, what's that, over 10 lines of code down to 1. And on the topic of operations, this one here is a little bit more real world. So again, I'm hoping I haven't cleaned up my hard drive, because otherwise this test is going to be not that great. But I've got, if I remember correctly, yeah. So I've got a hash table. Sorry, I've got an XML file on my hard drive. I'm hoping that has a hash table full of name and service ID pairs, and I made that XML file artificially large by repeating information in there and appending numbers against it. But what I wanted to show is how you can look for a target within a hash table and search for it. So how you might think to do that, if you don't necessarily know how to do it otherwise, is you'll look through each of the keys in your hash table, check to see if that matches your target. If it does, true, well, return true, and then break out of your for each. So part of the randomness of this test is you can't always be sure which order you're going to loop through your keys in. So if it literally finds that key in the first iteration, this is going to break out really quick. But it could also be the last key and take forever to get there. Alternatively, you just use the contains key method on the hash table, pass in what you're looking for, and through PowerShell and .NET Magic, it spits out true or false. And it looks like my file is there, because otherwise this would be sitting on 0 milliseconds, so that's good. And this one is well, it is close. It's 6% speed up. I thought I'd made this XML file a little bit larger to get some more out of it, but the random nature of it is I have seen this average as high as 20 milliseconds. I've also seen it beat this by about half as well, so I've seen that as the average on my control as low as 4 milliseconds. So I guess I'm just lucky that in this case it did actually go a bit slower than normal, or slower than it can. And again, this relies on knowledge of the language, at least as far as being able to discover that a hash table contains key method, and that you can use it to look up a specific key. And a final one on unnecessary operations is searching for a specific string in a bunch of text files. So the top two lines in both of these are going to be the same. I'm grabbing just text files out of my data file, and my target's going to be my name. Now my control here is piping that list of files, loading the contents into memory, and then searching for my name using select string. What I didn't realize, and what a lot of people don't seem to realize, is select string can actually load that text for you, and it does it really efficiently. So you don't actually need that middle step of getting the content yourself. And wow, that's close. I have a feeling we got lucky on a bunch of those tests. All right. I think I need to throw some extra large files into that directory. Actually, sorry, excuse the diversion. I'm going to quickly check that that folder actually, that'll do it. So I did clean up my data folder. I'm going to rerun a couple of tests here because I've got a backup of that folder. Right, let's go back to 7B. Is that XML file in here? It is. So let's look at the XML one again. That's a little bit better, but it's not quite as good as I was hoping. So yes, but 12% is closer to what I expect. I normally see about 15% on this specific example. But what I'm more interested in is rerunning this one where I'm searching for my name. So the good news is the test is taking longer to finish, which means it's actually having to do some work this time. There it goes. That's better. So yeah, when there's actually data for it to search through and files for it to load up, my control, where I'm using get content to load the text files in, and then searching for the strings takes 120 milliseconds. You shave off, what's that, 40? Excuse the back of the hand maths. Shave off about 40 milliseconds or a third when skipping that step. So a lot of that is the extra pipeline there, and some of it's also as the data set grows, you'll run into memory problems as well, and yeah, that's not fun. So I alluded to it a little bit earlier on, but there is also an overhead in using commandlets as opposed to .NET in and of itself. So both of these examples generate 1,000 GUIDs and just output them. So they'll end up on the console. The only difference being this one uses the commandlet and this one uses the new GUID constructor on the GUID class. This is probably one of the biggest differences of all of these examples, but the commandlet takes almost 100 milliseconds. Just by switching to that .NET notation, it's down to 2.4, which is massive. And again, but again, the problem with this is if you're not coming from a .NET language, chances are you're not going to know about that. And to be fair, it isn't as user-friendly to read. So once you know what you're looking at, you can sort of instinctively know that's creating a GUID, same as that's creating a GUID. But if you know about this notation and you don't mind using it, you are going to get a substantial speed up, again, of nearly 100%, just by making that small switch. Just to drive that home. There's another example here, and I wanted to call out where I saw this. It's slipping my mind. But I saw this come up on Twitter a while ago. And basically, my control here is I've got a root path, which is that data directory we've been dealing with. And I want to go through and join a bunch of paths and output the results. So for 1,000 items, I'm going to join the the child path, which is going to be a number from 1 to 1,000, to see data, spit out the results, using the join path commandlet. Like before, I'm switching join path over to IO path, and I'm using combine, and dropping in my root path and my number. This one's not as easy to make the transition to, in my opinion, compared to the new GUID one. But again, once you know about it, if you're comfortable using it, the speed up's about the same. In fact, technically this one's better, being 98% rather than 96 or 97. But yeah, so it's just that if you know the .NET, you're comfortable writing it, feel free to use it. You will get a speed increase. Some other examples I've seen are using the net connection class to ping things rather than using the test connection commandlet. Obviously, that's a decent speed up as well. Right, nearing the end of these. So I've been using collections and arrays sort of willy-nilly up to here, if I've been using them at all. And they do become a bit of a hotly debated topic online from time to time because everyone has their preferred way of dealing with them. But one of the most common ones you'll see is people creating an empty collection and assigning items to it with this plus equals notation. So in this, I'm just generating 1,000 random numbers, assigning it to my collection, and we're done. Now, instead of doing that, and this is my preferred way of working with collections, unless I need something a little bit more specific, is using an array list. So I've created that using new object, and then I use the .add method on that to add instead of this plus equals notation before. And you'll notice I've got null equals at the front. Now, if you've ever used an array list and added something to it, you'll see that it outputs the index of the item that it just added to the array list. We also saw earlier that output to the console can slow things down, so I like to silence that. And that also means that the output of both of these are exactly the same, and that neither of them are outputting to the console, and we end up with a collection called collection at the end. This is the biggest difference between the two, the biggest speed up. So this one being 99%. And again, we're going 166 milliseconds down to sub-milliseconds. Now, especially if you're coming from another language where you might use plus equals a lot, you might still feel more comfortable using just an empty collection. If you can make the jump to this or the next example I'm going to show, you're going to reap the benefits of it, but I won't hold it against you if you decide not to, because it is a bit of extra legwork to remember. Use the method, silence the output. If you don't silence the output, you're potentially going to have thousands of numbers up your screen, which isn't fun. But then the next thing you hear when you're talking about collections is, why don't you do it this other way? So I want to quickly touch on that. So in this one, my control is the array list, which was my variation from the previous one. And now instead of defining a collection, I'm just assigning the output of my for each loop directly into a variable. So we're skipping that whole initialization and then adding explicitly to the collection. And technically this is faster, at least for this data set. But just. Now, even though I know that for most of the data sets I use or work on in my day-to-day activities are going to be faster using this notation, I still personally use array lists. And that's just a decision I've made personally because I know and like this notation, and I also like the flexibility of being easily able to just opt out of adding specific things to my collection. And it's just one of those comfort blanket type things. Right. So you saw me use equals null before. And that, just like before, where I said using array lists is my personal preference, using null equals to silence output is my personal preferred way of doing things. But there are a couple of different options up your sleeve. So PowerShell has an out null commandlet, and you can pipe output to that. But as we know, the pipeline's going to have overhead, and strictly speaking, so is the commandlet. So I wanted to quickly show the difference with the control and my variation being the same except for out null versus null equals. And again, the difference is huge. And that comes down to the pipeline and the commandlet overhead. So, yeah, 100 milliseconds down to sub-millisecond. So it's obvious why I choose out null versus null equals. However, let's look at a second option for silencing output, which is casting my output to null. So in this case, I'm comparing null equals, casting to void. So the result of these two are going to be identical. And again, the control and the variation are exactly the same except for null equals versus void. Strictly, normally when I run this is about what I get, with null equals being quicker, but there's bugger all in it. So whichever one of those you prefer, I'm not going to hold it against you. But what I've found is void doesn't always work, whereas null equals are pretty reliably going to work regardless of the situation you throw at it. So I prefer that. One of the other options you can use is redirecting to null. But for me, I don't really look that far along my lines to see what's happening down there. I'm used to seeing null at the front, and if I see that, I know, that must be noisy, and I'm trying to silence it. So again, personal preference. Right, and the last one of our mainline demos is the mother of all speed-ups, which is doing things in parallel. So this one gets a little bit wonky because I'm running posh RS job within a posh RS job. But the idea here is, with my control, I'm going off to the internet and I'm pinging 4 different targets. So we've got a couple of DNS servers and a random news site from New Zealand. For each of those targets in my control, I'm going to ping them using quiet so that it only returns true or false, and then I'll output an object with the host name and whether or not it responded. So if you think about that, that's going to take each of those addresses, send 2 echo requests at it, wait for a response, deal with it, output the object, move on to the next one. My variation is taking all of those targets, piping them through to start RS job, and spinning up a script block. So this script block is going to execute for each of those, and it's going to do it in parallel. So the analogy I like for this is a supermarket. So assuming everyone has the same amount of groceries in their basket, let's say it takes a cashier 30 seconds to process each person. If there's 4 customers with 1 checkout operator running, it's going to take them 2 minutes. I forgot my own maths there for a minute. It's going to take them 2 minutes to get through all of the customers. But if they open up a second checkout, all of a sudden they can split that load and they're done in a minute. If they open up 4 checkouts, everyone can go through at once, they're done in 30 seconds. So logically, you'd expect doing them all in sequence versus all at the same time, when you're dealing with a set of 4, to be about a 75% speed up, i.e. it takes a quarter of the time. And it gets close to that. But the reality is there's some overhead in setting up those parallel jobs. But yeah, it's still going to be dramatically quicker. And I like this one because it actually gets up into the seconds. So my control, when I'm doing everything one at a time, we get close to 6 seconds. We shave that down to 6 when we do things in parallel. So that's parallel. Posh RS job is just my preferred module for carrying out parallel jobs, and it's really good, so use it. Now really quickly, we'll do a bonus round comparing Windows PowerShell to PowerShell Core. So the blue console, Windows PowerShell 5.1, the right console, PowerShell 6, and should be specifically 6.1. In fact, let's check. It is PowerShell 6.1. So, I'm just reusing my new GUID example from earlier. And what you're going to see is, for the most part, PowerShell Core is a little bit quicker side by side. So for generating my 1000 GUIDs, Windows PowerShell 389 milliseconds on average versus 322 in PowerShell Core. Let's quickly run another one. Didn't get the new line on that, so it didn't run. But this is my building a collection of random numbers. But instead of just 1,000 random numbers, we're doing 50,000 random numbers. And in this one, Windows PowerShell actually ekes out the win, being 89 versus 108. Now what I've found, and I found this because of the documentation from Microsoft, is that PowerShell Core actually does a really good job of dealing with large data sets. So one of the specific examples Microsoft gave in their release notes was how the group object, sorry that's wrapped around because I made the text a little bit too big, but group object has been sped up dramatically. And what I found when I ran my own test was that no, it's not, because Windows PowerShell here is 66 milliseconds. Windows PowerShell 66, but PowerShell Core is 76. So that doesn't look fast to me, but that's only getting 1,000 random numbers and then grouping them. What happens if you bump that up to 100,000 random numbers? And this one takes a little bit longer to run, so I probably should have started it sooner. But you'll see, PowerShell Core is already finished. It took 8 seconds on average. And I probably shouldn't say on average because I've dropped the iterations down to 1. But Windows PowerShell took 18 seconds, a full 10 seconds more. So we've gone from grouping 1,000 items, being quicker with Windows PowerShell, to grouping 100,000 items, being quicker in PowerShell Core, by a large percentage. And I found that to be the case pretty much across the board. If you throw large data sets at PowerShell Core, it's going to be quicker than Windows PowerShell. But if you've got small data sets, Windows PowerShell tends to take it out. And they're always adjusting these things, so it pays to double check, as new versions come out. So that's all the examples done, and I guess coming out of all of those is, are these examples a silver bullet? And the hard truth is no, they're not. Because depending on your data sets, you might run into memory consumption issues, you might run into CPU bottlenecks, which necessitate you doing things in a specific way, which aren't as fast, but they'll actually finish the job without crashing. If you start implementing these willy-nilly, you might end up breaking a working script, and we'll talk about that in a second. And frankly, your environment is a snowflake. So a lot of these examples work for me, but they might not work for you in your specific environment, on your servers, with your hardware. So the takeaways from this is, don't assume. Just because you've always done something one way, doesn't mean that's the quote-unquote right way to do it, or the best way to do it. It might be, but you're not going to know unless you try unless you try the alternatives. Measure twice. Like I said at the start, random occurrences happen. Some of these tests didn't work out the way I expected them to. So yeah, it always pays to measure multiple times to get as true as possible reflection of reality. And revisit, especially now with PowerShell Core having quite regular releases. It always pays to save your tests that you've done, rerun them, check to see if things have changed, because especially at the moment, they do regularly. And worry about optimization after it's working. So if some of these things I do naturally now, because I've seen them work, I've done them enough that they're second nature, I just do them. But if it's not second nature to you, don't worry about implementing them yet until your script is working and you actually want to go and get those speed increases, because not everyone does and not everyone needs to. And finally, test your code. If you've got decent test cases set up for your modules, for your scripts, you should be able to tell pretty quickly if one of these optimizations have broken something. So, thanks Mike and Ron and the Mississippi crew. It's been great speaking again. You can find a copy of the slide deck at the bit.ly link on screen, and you can reach out to me on Twitter.
Well, thank you, Josh. Does anybody have any questions?
Josh,
Yo.
the I ran across something a while back where they were talking about that the array list, systems.collections array list was being depreciated. You're starting to look at using system.collections.generics. Have you looked at that?
Not yet, and part of that is mainly because day to day I'm working purely in Windows PowerShell, so I'm not really affected by that sort of stuff too much. But yeah, it's stuff like that, and also using the generic line breaks that I need to get used to as well, because Windows line breaks aren't going to cut it for long.
Yep, and I think the generic collections, they're essentially array lists, but they're strongly typed. So you
Yes.
create like a
Yes.
a string, a generic list of strings, and then they're all strings. So an array list is like a generic object, so it can hold anything. And to do the same thing with a generic collection, you would just have the type be object or PS object. I hadn't heard that they were deprecating it, but I do know that in the C# world, you would look to generics, probably, because again, it's strongly typed. But in PowerShell, because you have that loose typing already, I generally just stick with array lists myself. But there's nothing wrong with going to do the generics.
Unfortunately,
Why not
I've got to
use-
run. I'm getting a bit of a poke from the family. But if you've got any other questions, do hit me up on Twitter, and I'll have a look when I get home later on.
All right.
Good
Well,
job.
thank you, Josh.
Awesome.
Yeah,
Thanks
thank you,
again for
Josh.
having me.
All right.